insulation. Now they slide two sheets together to form a panel. They close off the ends with blocks of pine. This will prevent cold air from penetrating inside. They apply various stickers with installation, maintenance, and safety information. Then orange stick-on dots to mark the location of the metal plates into which the installer will screw the hinges and lift handles. Now they attach an aluminum bar to the long ends of each panel. This holds the panel steady during the injection process. After injection, the bars come off. They load the panels onto a carousel and begin the process of filling the hollow interior cavity with insulation. Through the hole they drilled earlier, they inject polyurethane foam, an expanding plastic insulation material that's specially designed to penetrate hard-to-access spaces. As we see in this demonstration, the polyurethane expands and becomes rigid. This creates a solid core inside the garage door. Polyurethane is one of the lightest types of insulation, so it doesn't make the garage door heavy. Here's what the inside of a panel looks like once the foam hardens. Now, workers install various components, such as the rubber weather seal on the bottom panel. This seal prevents cold and water from entering the garage under the door. Some garage door models have windows to allow in natural light. Workers first use a high-speed router to remove the rectangles where these windows will be installed. Then they insert one of several window styles available. These are double-sealed windows, two thermal panes with an aluminum spacer in between. The framing around the glass is available in different colors. It's made of PVC, a synthetic resin that doesn't discolor. The frame prevents water and cold air from penetrating. Workers pack the installation hardware. Then they weigh the box to ensure no part was left out. At installation time, they attach the door panels at the joints with hinges. A system of springs ensures the garage door is perfectly balanced and moves smoothly. If properly installed, you should be able to lift or lower the garage door using just 2 fingers. Electric motors are made up of 2 main components, one stationary, called the stator, the other a rotor that moves inside the stator. The stator has multiple wire coils. Running electricity through them creates a concentrated magnetic field that turns the rotor, creating mechanical power. The stator is lined with slots, each of which holds a copper coil. The more powerful the motor, the bigger the stator and the larger the slots. The first step is to line the slots with insulation. This insulation will keep the voltage confined to the coils. The coils are made from several copper wires wound together by programmable machines. The bigger the motor, the more wires per coil. In this motor, each coil consists of 13 strands of copper wire. Now workers tie the coils. This prevents the wires from unraveling while being inserted into the stator slots. Workers cap each coil with fiberglass insulation. Then they insulate the portion of the coil left outside the slots with fiberglass sheets. Then they insert fiberglass wedges to lock the coils inside the slots. Once all the coils are inserted and insulated, workers begin preparing the connection. They slip an acrylic insulation sleeve over both ends of each coil. 13 coils, 26 ends. Then they group these insulated wires into large power cables. The number of wires per cable varies according to the speed and voltage of the motor. They solder the grouped wires together, then insulate the cables. They tuck some inside the stator and leave others accessible to be attached to a power source when the motor's installed. Now, using a cord made of heat and chemical-resistant polyester, they bind the coils tightly to ensure they won't move when the motor spins. This unit of bound coils is known as the stator coil. They now submerge the stator in a polyester-based varnish and vacuum it right through. This thorough penetration makes the stator coil moisture-resistant. Then they put the stator into an oven for 6 hours at 135 degrees Celsius. The varnish hardens, making the stator coil rigid. Now they have to balance the rotor. If it's off kilter, the motor will vibrate, hampering performance. They balance it the same way a mechanic balances car tires, only with 100 times greater precision. Now they slowly slide the rotor into the stator, careful not to damage the stator coil. The rotor will turn on steel bearings. They heat these bearings to expand them so they'll install easily. Then they blow on cold air to shrink them to a tight fit. It's the same process with the motor's back cover. Now they heat the fan and install it over